Hi guys, welcome to my channel. Today we are diving into an essential topic for anyone involved in AI, understanding the AI model lifecycle. This process involves multiple stages, each with unique challenges that must be addressed to create successful AI models. From defining the problem to managing the model's end of life, organizations face various hurdles in developing, deploying, and managing effective AI solutions. In this presentation, we'll explore the common challenges at each stage of the life cycle and share practical strategies, along with real world examples to overcome them. By tackling these obstacles, you can develop AI models that are robust, accurate, and deliver meaningful business value. Let's start with problem definition. It's the foundation of any project. If the objectives are unclear or feasibility isn't assessed early, the project can derail quickly. For example, imagine an AI model designed to predict customer churn. If the goal is vaguely defined as reduce churn without specific metrics or targeted outcomes, the model might fail to meet business needs. Engaging stakeholders ensures that goals are well defined and aligned with business needs. A proof of concept is crucial here. It helps assess feasibility before committing to full scale implementation. Having a clear problem definition reduces risks, guides the choice of methods, and increases the chance of success. Next, we move to data collection, the backbone of any model. Data scarcity and poor quality are common challenges that threaten a model's accuracy. For instance, in a healthcare project aiming to predict patients' outcome, you might face limited data on rare conditions. Data augmentation techniques can expand your dataset, and rigorous data quality assessments ensure the information is clean, consistent, and trustworthy. Addressing these challenges early sets the stage for building robust AI models that perform well in real world scenarios. After collecting data, the next critical step is data preparation and feature engineering. This process is essential for ensuring that your data is clean, consistent, and ready for analysis. Often, you'll need to integrate data from multiple sources, each with different formats, structures, and quality. Implementing a robust ETL process is vital to clean, transform, and combine these data effectively. Once the data is prepared, feature engineering becomes the focus. This involves creating new variables or modifying existing ones to enhance the model's predictive power. For instance, you might engineer features like customer interaction frequency or transaction patterns in a sales dataset to improve prediction accuracy. However, this process can lead a high dimensionality where the dataset has too many features. High dimensionality can cause overfitting where the model performs well on training data but poorly on new unseen data, and it can also increase computational costs. To tackle this, dimensionality reduction techniques like principal component analysis and feature selection are used. PCI reduces the number of features by transforming them into smaller set of uncorrelated components while retaining most of the original information. Feature selection, on other hand, identifies and retains only the most relevant features. For example, in a dataset with hundreds of variables, applying PCA can reduce the features to a manageable subset, simplifying the model and improving its generalization without losing critical information. By carefully managing data preparation and feature engineering while addressing high dimensionality, you ensure that your data is both powerful and efficient for model building. Now, let's move on to model building and evaluation. One of the critical steps here is algorithm selection. The choice of algorithm depends on the nature of the problem, the type of data, and the desired outcomes. For example, decision trees are easy to interpret but might overfit, while neural networks are powerful for complex tasks but require more data and computation. The key is to evaluate factors like accuracy, speed, interpretability, and scalability to ensure the chosen algorithm meets your project's specific needs. Next is overfitting prevention, which is crucial for building models that generalize well to new data. Techniques like regularization, cross validation, and pruning helps keep the model simpler and more robust. For instance, dropout in neural network randomly omits some connections during training to avoid over reliance on specific nodes. These techniques collectively ensure the model perform well on unseen data. Selecting the right evaluation metrics is also essential. For example, in a medical diagnosis model, accuracy alone may not be sufficient. Precision and recall might be more important to minimize false negatives. Depending on your business model, choosing the right metric ensure your model aligned with those objectives. Finally, fairness audits are crucial for identifying and mitigating biases in your model's prediction. For example, a hiring algorithm should be checked to ensure it doesn't unfairly favor or disadvantage certain groups based on gender, race, or age. By conducting fairness audits, you can build trust in your AI system and ensure ethical AI operations. Once the model is built and evaluated, it's time for deployment. One of the key challenges during deployment is scalability. For instance, a recommendation system for an e commerce site might work well during normal traffic, but what happens during peak shopping seasons? The model needs to scale automatically to handle increasing loads, which is where tools like Docker, Kubernetes comes in. They allow model to be portable and scalable across different environments. Another deployment challenge is integration. AI model often requires specific environments or dependencies which might conflict with the existing infrastructure. For example, deploying a Python based model into a Java based enterprise application can lead to compatibility issues. Containerization with Docker can help, but integration the model with another services and ensuring smooth communication, perhaps through APIs, still requires careful planning and coordination. Once the model is deployed, monitoring and maintenance become critical. Tools like Prometheus or Grafana can track key metrics such as accuracy, response time, and data drift in real time, ensuring that any performance issues are quickly identified and addressed. There are also several cloud based tools that offer monitoring, observability, and alerting features. Popular options include Amazon CloudWatch, Azure Monitor, Google Cloud Monitoring, Datadog, New Relic, and Splunk Observability Cloud. These tools provide comprehensive insights into your model's performance, helping you maintain optimal functionality across various environments. Periodic retraining is another vital aspect of maintenance. For example, an e commerce recommendation model initially trained on last year's data might become less effective as customer preferences shift. By retraining the model regularly with new data, you ensure it stays accurate and relevant over time. Finally, model drift detection involves continuously monitoring the data that the AI model processes to identify shifts that could negatively impact performances. For instance, a credit scoring model might face drift during an economic downturn when applicant behavior changes. Detecting this drift early allows for timely retraining, ensuring continued accuracy and effectiveness. Gathering user feedback is crucial for continuous improvement. For example, a customer service chatbot might struggle with understanding regional slang. By analyzing feedback and interaction data, you can update the model to handle these situations in a better way. Regularly analyzing performance allows you to spot areas for improvement. For instance, if a model's accuracy drops, analyzing its predictions can reveal why and guide necessary adjustments. Once issues are identified, it's important to take action quickly. Using agile methodologies, you can effectively implement changes such as retraining the model, adjusting its parameters, or updating its data sources to ensure the model remains accurate and effective. Finally, educating users is crucial for the correct use of the AI model. Providing clear documentation and training helps users understand how the model works, recognize its limitations, and interact with it effectively. This not only builds trust in the model but also leads to better outcomes. As AI models age, they may face obsolescence. For example, a network security model might struggle to keep up with new types of cyber threats. Regularly adopting cutting edge algorithms and refining the model's architecture are key to staying ahead. Finally, technical debt can accumulate over time, making future updates more difficult. By adopting a modular design, you can manage these steps more effectively. For instance, if a specific feature needs an update, only that module needs modification, minimizing disruption to the entire system. Mastering the AI model lifecycle is vital for developing AI solutions that are both effective and sustainable. By systematically managing challenges at each stage, from problem definition and data collection to deployment and eventual re engineering, organizations can create models that are robust, accurate, and reliable. This disciplined approach not only enhances the performance and longevity of AI models but also maximizes their business value, fostering innovation and maintaining a competitive edge in the market. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more insights into AI and technology. See you next time.